So let's talk about the distance, well, the rate time distance formula. So let's say I drove to Price, um, and I'm slow. I drive 55 miles per hour on my motorcycle that died over the summer, so tears. Well, it's not totally dead. Now 55 is as fast as it will go. So, so if I drive 55 miles per hour for, let's say, oh, I don't know, it takes me 38 minutes to get where I'm going. I want to know how many miles did I travel. Well, what's the formula that we're dealing with? So, close. Rate times time equals distance. No, you said rate times distance equals time. Yeah, it doesn't work that way. Okay, well, I have a problem. There's a problem in here. One's in hours and the other's in minutes. So I need to change this one to hours. How do you change minutes into hours? Divide by 60. So 38 divided by 60. So that tells me what? 0.63 hours. Now I just plug this into the formula. 55 miles per hour, that's my rate, times 0.63 hours is going to equal my distance. So 55 times 0.63, and I drove somewhere that was 34.65 miles away. Okay. Let's change it a little bit. Let's say I drove for that's a 3. How about 3 hours? And I traveled 195 miles. What was my rate? So I'm going to plug them into the formula. My hours is 3, so 3 times R equals 195 miles. Divide by 3. 195 divided by 3. Wow. Apparently I'm not in my motorcycle anymore. Okay, now, one thing that we need to talk about is, if I'm driving to Price at 50, am I actually going to drive 55 miles the entire way? No. So what does that 55 miles per hour tell me? It's the average speed. Because when I started, I was going 0, and I had to speed up to 55, which takes a little while on my bike. And then you had to drive through Huntington, so you have to slow down. And there was that deer in the road that you swerved to miss. And you passed a semi. So this 55 miles per hour is the average speed. Yeah. Or semi passed me. One of the two. So if this speed is my average, then my maximum speed is going to be higher than the average. How do I know that? Well, how can I guarantee without knowing anything else about the story that my max has to be bigger than that? Why is 55 not my maximum speed? Okay. Well, true, true, but okay. So you're saying, does anyone have another way to explain that? I think you're right, but I'm thinking about it differently. How do I know that I went faster than this? If I started at 0 and sped up to 55 and drove 55 the whole way, would my average speed be 55? No. because I can guarantee at some point I'm traveling slower than 55, which means that my max would have to be higher than the average to make up the difference, which I think is what you were trying to say. Yeah. Okay. Well, what if I have an average speed, let's say I drive from here to I-70, and my average speed is 65. Then I get on the freeway, and I drive to St. George, and my average speed is, there are stretches on that road where it's 80. So let's say that my average speed was 77.5. Where? Oh, cool. So if I drove 65 for a certain amount of time, and then I drove 75 for another certain amount of time, there's another formula that deals with two different speeds. Okay? So we can take rate times time equals distance. And if we wanted to solve that for time, it would be time equals distance over the rate. Okay? So if I drove 65 miles per hour for, I don't know, how long would it take to get to I-70? Maybe 3/4 of an hour. So for 0.75 hours. And then you're probably looking at another 3 hours to get to St. George. So I drove an average of 77.5 for 3 hours. Then how far did I travel? Well, I need to adapt this formula to fit 2 speeds and 2 times instead of 1. So my new formula is going to be time, nope, yeah. No, wait a minute. Oh, I got this backwards. Well, we'll figure it out. So, how would I calculate the total distance here? So, the problem is I wrote this the wrong way. So, oh, I see what I did. I just got ahead of myself. Okay, so let's figure the rate times time of the first one. So 0.65 times, 65, times 0.75 equals, did somebody do that? That's not right. 65 times. So what does that tell me? So from here to I-70 is 48.75 miles, which is actually pretty close. Okay. Now what do I need to do? Do the other one. 77.5 times 3 equals 232.5. And then add those two together, and I get 81.25. Okay, let's see if we can come up with a formula that will allow us to work backwards in a problem like this. So let me erase this much. So what we did was rate times time, which this is equal to some distance. We'll call it d1. So our first rate times our first time equals our distance 1. And we added that to r2 times t2, and that equaled our total distance. Does that make sense? So really what we have is d1 plus d2 equals our overall distance. Okay? So what if I didn't know one of the times? So let's say that my R1 equals 40 miles per hour, and my T1 equaled 2 hours, and then my R2 was unknown, but my T2, so I travel 40 miles an hour for 2 hours, I travel an unknown speed for 3 hours, and my total distance was 200 miles. 200 miles. Oh, shoot. I made that too easy. 240 miles. So let's plug everything in. 40 times 2 plus something, R2 times 3 equals 240. How do we solve for this? So this is 80. What do I do with that 80? I'm going to subtract it from here, and I get 3R2 equals 240 minus 80. Okay. Divide by 3, and R2 is going to equal 53.3 repeating. So that is the average speed for that second stretch. Okay. Find this other formula. Hang on a second. So let's look at this particular equation a different way. Here is one rate time distance equation, and here is another rate times distance equation. So I have R1 T1 equals D1, and R2 T2, oh boy, that's not a Star Wars joke, equals D2. What if I solve both of these for time? So T1 is going to equal, how do I solve this equation right here for time? Divide by the rate. So D1 over R1. And down here I have T2 equals D2 over R2. Well, so if I took the first distance and divided it by the first rate, and added that to the second distance divided by the second rate, what is that going to equal? Your first time and your second time together, which we're just going to call t. Okay? So you might need either this formula or this formula, or you could also solve for the rate, but the rate is going to be an average rate, which doesn't really make sense. I don't think they're going to do that to you. If they do, then I'll teach you the other formula. Okay, so did I hand out those worksheets? Come grab one of these worksheets, and we'll do a couple problems together. All right, look at number 1. And if you want, you can get online, and the answers are online. I'll post them up here in a little bit. Stefan left school and traveled towards his friend's house. Eugene left 2 hours later, traveling at 40 miles per hour in an effort to catch up to Stefan. After traveling for 3 hours, Eugene finally caught up. What was Stefan's average speed? So there's really not one way to solve these. One of those formulas I taught you is going to end up working. But I would start with the most basic rate times time equals distance, and then go from there. And maybe you'll have to use the more complicated one with the R1 and T1, but we'll see. So let's make a chart for Stefan and for Eugene. So what do we know about Stefan? Okay, so he left earlier than Eugene did. So Eugene traveled for how long to catch up? So Eugene traveled for 3 hours. That's Eugene's time. How long did Stefan travel? So Eugene left 2 hours later, so Stefan must have traveled 5 hours. Okay. Eugene traveled at 40 kilometers per hour. All right. So we're looking for how fast what was Stefan's average speed? How are we going to figure that out? So I'm going to do rate times time equals distance for Eugene. So 3 times 40 equals 120 what? Kilometers. So after 3 hours, Eugene had traveled 120 kilometers. How far did Stefan travel? So the way this story works is Eugene takes off, and he travels for 5 hours. Stefan leaves 2 hours later, and at this point, at the 5-hour mark, oh, sorry, did I say the wrong name? Yeah, okay, switch the names. So he finally catches up, and he travels for 3 hours, but because he caught up, we know that the distances are equal. So Stefan also traveled 120 kilometers, and we're looking for his rate, so we can plug these numbers in here. So R times 5 hours equals 120 kilometers, and you just divide by 5. 24. So Stefan was only traveling 24 kilometers per hour. And you need to make sure that you always label the units on problems like this. Okay, let's do number 3. Shayna? Where do they get these names? Sorry if any of you have Shayna siblings. Shayna left the airport and drove towards the capital at an average rate of speed of 52 kilometers per hour. Sometimes later, her friend May left driving the same direction but an average speed of 65 miles per hour. After driving for 4 hours, May caught up with Shayla. Find the number of hours Shayla drove before Maya caught up. Okay? So, organizing the information is probably a good idea. We know that Shayna's speed was 52 kilometers per hour. Sometime later, May, we'll call her May, left driving at the same direction but an average speed of 65 kilometers per hour. They must be on my motorcycle driving that slow. After driving for 4 hours, she caught up. So what are we looking for? So we want to know how long Shayna was driving total. So we want to know how many hours. There's no distance here. What do we know about the distance? It's the same on both sides. Do we know what the distance actually is? We can figure it out. So we multiply 65 times 4, and you get 260 kilometers, and that's how far May drove. So if we plug Shayna's information in, R times T equals distance. So we're going to plug 52 in for the rate, times T equals 260. And then we just take 260 and divide it by 52. So she drove 5 hours. Okay, let's do number 4. Lisa traveled to her cabin on the lake and back. The trip there took 5 hours and the trip back took 6. She averaged 45 kilometers on the return trip. Find the average speed of the trip there. So now we have two distances. We can use that fancy formula I came up with. D1 over R1 equals, actually won't let us. 5 hours, nope, never mind. Let's not use that formula. Okay, so let's write the trip out and the trip back. So the trip out took 5 hours. The trip back took 6 hours. What else do we know? So 45 kilometers per hour, which is really slow. That's like 28 miles an hour, maybe 30 miles an hour. Yeah. So we want to know the rate over here. Maybe we don't even need that fancy formula. This looks like it's easier than that. So what are we looking for? Or what do we need to find out the rate? We need the total distance. So rate times time equals distance. We can find all of that out from the trip back. So 6 times 45. That's 270 kilometers. How do we find the rate on the trip out? Well, I'm going to plug 5 in for the time and 270 in for the distance. So 5R equals 270 divided by 5. So 270 divided by 5 is 54 kilometers an hour. And maybe I went too far. I thought we were going to need that fancy formula, but so far we haven't needed it. So, yeah, it looks like you're not going to need that fancy formula. So your assignment is just to finish this worksheet. It will be due tomorrow. Good luck.